So how do you take a messy pile of old construction debris and turn it into a super valuable industrial product? Today, we're popping the hood on 95wood.com to find out. We're going to break down their entire tech architecture piece by piece and see exactly how they use data to turn waste into a genuine asset.
And this quote right here, it just nails the core idea. We're not talking about your average bin rental company. The whole operation is built on a fundamental shift in thinking. It's moving away from simple logistics, just hauling trash, to this really sophisticated digital workflow that processes and refines physical material.
All right, so here's our game plan. We'll kick things off with that core digital refinery concept. Then, we're going to follow a piece of wood waste on its entire journey through 4 distinct technology tiers. From the first automated phone call, to on-site AI analysis, to heavy-duty scientific validation, and finally, through the automated compliance and billing engine.
Okay, so this gets right to the heart of the problem the whole system is designed to solve, what they call the quality gap. On one hand, you've got this chaotic, messy pile of wood from a demolition site. On the other hand, you have the bioeconomy, which needs an incredibly pure, consistent raw material to work with. This digital refinery, it's the bridge that connects those two worlds.
And wow, this slide just lays that quality gap out perfectly. These big industrial off-takers, the folks making things like renewable natural gas, they can't just take a pile of old 2x4s. They need a precisely engineered feedstock. We're talking less than 1% contamination, under 10% moisture, and a particle size that's just so. The difference is literally night and day.
So, to manage all this in a real world, the system uses a classic hub-and-spoke model. Just think of the smaller 20 and 40-yard bins as the spokes, out there collecting wood from job sites all over the region. They all feed back into one central hub in Hamilton, and that's where the wood gets validated and processed before it's loaded onto a massive 144 cubic yard trailer, they call it the mothership, for super efficient long-distance transport.
All right, let's dive into the first layer of the tech stack, Tier 1, Automated Intake. This is the digital front door. It's the very first time a customer actually interacts with the refinery.
And this is where you see the first massive jump in efficiency. I mean, you'd be shocked, but a lot of the waste industry still runs on this incredibly analog system of phone calls, fax machines, and spreadsheets. It's crazy. 905 Wood just throws all that out and replaces it with a 24/7 automated system that gives you that instant app-like experience we all expect now.
So, how's it work? Well, a customer calls the toll-free number or just shoots a message over on WhatsApp. A ChatGPT bot handles the first part of the conversation, getting the basic info. That request then flows through a cloud-based phone system, which basically replaces an old-school office switchboard, and plugs right into the dispatch workflow. It's a completely seamless, totally automated process.
Now for Tier 2, Edge AI Triage. Okay, this is where the digital part of the refinery gets really cool. We're actually moving the intelligence out of the central office and putting it directly into the field. We're talking about making critical decisions right there on site, before a single truck even starts its engine.
But wait a second, this raises a huge question. We're talking about using a smartphone to check for potentially hazardous waste. Can a simple camera really spot invisible chemicals like the arsenic you find in pressure-treated wood? Well, the answer is kind of no, but also yes.
The magic here is a concept called multimodal reasoning. The system uses a modern smartphone not just as a phone, but as a powerful little computer right there on the edge. A special AI model runs locally, right on the device's chip, and this lets it combine different kinds of data, like what the camera sees and what the microphone hears, to make a much smarter decision, even if there's no internet connection.
Okay, here's a perfect example of how that works in the real world. Imagine the AI's vision model looks at a pile of weathered wood and says, "Yep, that looks clean." But then the driver records a quick voice note, tearing down an old deck. The AI agent on the phone hears the word deck, understands that deck often means treated wood, and it sees a conflict with what the camera saw. So it automatically overrides the clean classification and flags that entire load for mandatory screening. It's the precautionary principle, completely automated.
So that flagged load gets sent right here to Tier 3, the central hub. This is the physical spot where all those spokes of the logistics model come together, and it's where that initial AI guess gives way to hard science and industrial physics.
And this slide introduces a concept that is absolutely crucial to understand. Wood waste isn't like a pile of rocks. It's not inert. It's biomass. It's a biologically active material that is constantly changing and degrading. It effectively has a shelf life.
And that's exactly why the system follows a super strict first-in, first-out protocol. Now, in this world, FIFO isn't just an accounting term, it is a critical safety and quality measure. A manufacturing execution system, or MES, keeps track of how old every single pile is, making sure it gets processed before it degrades, loses its energy value, or even worse, starts to self-heat to the point where it could spontaneously combust.
And this is where the system gets the final, scientific proof that a smartphone just can't provide. At the hub, they bring out the heavy-duty industrial sensors. They use X-ray fluorescence, or XRF, which basically blasts the material with X-rays to find the specific elemental signatures of heavy metals. Then there's hyperspectral imaging, which can literally see chemical contaminants that are invisible to any camera. And finally, the material is processed into those perfect little chips that the bioeconomy needs.
Which brings us to our final layer, Tier 4, compliance and billing. This is the automated legal and financial engine that, honestly, makes this whole thing possible from a business perspective.
The core tech here is something called Retrieval Augmented Generation, or RAG. And the best way to think about it is like an open book exam for an AI. A standard AI might just guess or hallucinate an answer, but a RAG system can't do that. It is forced to look up the answer in a specific textbook. In this case, the full text of Ontario's environmental law, Regulation 347, and then cite the exact passage it used.
And here's what that looks like in action. It's perfect. The system doesn't just spit out rejected. It gives a legally defensible reason citing the exact section of the law that was violated, right down to the specific chemical limit. This creates an absolutely ironclad audit trail.
Now, underneath this whole engine is some seriously powerful enterprise-grade software. It uses a specialized AI database for incredibly fast searches, letting it compare waste profiles to legal rules in a split second. And that's all paired with a robust e-commerce platform to handle all the complex billing on the back end.
So let's bring this all together and talk about the future of waste. Because what this whole four-tier stack really does is achieve a fundamental transformation. It turns something everyone sees as a liability into a verifiable, valuable asset.
144. That's the number of cubic yards one of those mothership trailers can hold. That single number gives you a real, tangible sense of the massive industrial scale this sophisticated digital system is built to manage. We're talking about consolidating the work of 5 or 6 regular dump trucks into one single, efficient trip.
And that's really the punchline. At the end of the day, this 4-tier digital refinery does way more than just move trash around. It transforms physical wood waste, a liability, into a verifiable, auditable, and truly valuable digital asset that can help power the circular economy.
And that leaves us with one final thought to chew on. This whole complex architecture was designed to refine one very specific type of waste. But if you can apply this level of data, AI, and logistics to turn wood waste into a high-value asset, what other materials that we call waste right now are really just a refinery waiting to be built?